Right, here's another example. So just pause while you write that one down and have a look at it. So for this example, if we compare it with the ones we've had before, we've only had x appearing once, or theta, or whatever it is. You know, x has only appeared once in all the ones that we've looked at so far. Now, well, x is theta, that's not a problem. The variable here is theta, and I'm integrating with respect to theta, so that's fine. The fact that it's a different symbol doesn't matter. However, I do have two functions multiplied together that involve theta. That might well be a problem. That's new. And it's certainly not a standard integral. We've also got sine 5 theta to the power 5 theta. And as a reminder, sine to the power 5 theta means, sine theta to the power 5 we write as, come on, you little. That's shorthand, isn't it? So it actually means sine theta to the power 5, that does. So, well, what a good substitution, and you were saying, Lewis, you know, what do you call u? In examples like this, I'm going to let u equal sine theta, because then I'll have u to the power 5, and that's a standard integral. We're going to have to worry about this, the fact that it's multiplied by cos theta, but we'll see that actually, I know, you know, from practice that's not going to be a problem in the end, but we're going to have to worry about that too. And so we start off by making that substitution. We're going to let u equal sine theta. So in problems like this, that's what we'll do. So now we follow the same steps. We've written these steps down. So step number 2, differentiate it. Du by d theta this time. Differential of sine theta is cos theta. Yeah. And now, what do we do? So now we've got to find out what d theta is. And actually, if this always works pretty well invariably, because the d theta, the thing you're trying to find, is at the bottom, because you've differentiated with respect to that, that comes up to the top over here, and the cos theta comes down. So that's effectively what happens, but it's a little algebraic manoeuvre anyway. So in other words, d theta equals du over cos theta. Next step is to make the substitution. So I'm going to go back to my original integral, and I'm going to let sine theta equal u and d theta equal du over cos theta. So the original integral becomes, integrate between 0 and pi over 6 of u to the power 5 times cos theta, but now times du over cos theta. Pardon? Is there a 24? Oh yeah, thank you. Now we see that these cos thetas disappear, look. They cancel. If they hadn't have cancelled, we'd have been stuck, because we're trying to now integrate with respect to u, but theta's still there. In all the examples we've looked at so far, when we made the substitution, the original variable disappeared. And that's one of the criteria for this to work. And in this case, because, and only because, the original integral had cos theta there, and if we think about the substitution idea for a minute, because I know I'm going to make this substitution, I'm going to let u equal sine theta. I've got that in my mind, and I know that the differential of sine theta is cos theta. And so I know that the cos theta is going to go underneath here. So I know that this is going to work, because when I'm going to have a cos theta underneath, that's going to cancel that out, so I don't need to worry about it. And that's why it works. if I wanted to just integrate 24 sine to the power 5 theta, I couldn't use this method. The fact that this cos theta is there means that it works, because when we get to here it cancels out. So one of the reasons, or the main things you must think about when you use substitution method is, when you make the substitution, the original variable, in this case theta, must disappear, and it does. So we can carry on. So we can now bring the constant outside, and we're going to integrate between 0 and pi over 6 u to the 5 du, and that's a standard integral. So now we can carry on, replace u with the original thing. Sorry, we've got to do the integral, I haven't done that yet. So that's going to be 24 u to the 6 over 6 between 0 and pi over 6. Add 1 to the power, divide by the new power. The 6 can come outside. 24 over 6 is 4. So we end up with this, u to the 6 between 0 and pi over 6. And now we can replace u with sine theta between 0 and pi over 6. And now it's just a case of putting in the limits, and out comes the answer. Don't forget the power 6 yet, sine theta to the power 6 or sine 60. So at this stage, don't forget this sine to the 6 theta means sine theta to the power 6, so we're going to end up with sine of pi over 6 to the power 6, and that's how I do it in the calculator, minus sine 0 to the power 6. Well, that's sine of 0, 0, so this term's gone. So I just got to work out what sine to the sine pi over 6 is, and then to the power 6. Don't forget you need to be in radians. Answer 0.0625, exactly so. That's actually incidentally shows quite a good case for always putting the significant figures, because now I know that's an exact answer, it's not been rounded.